Welcome back. Today I'm going to be going over this SAT constant question. And once again, thanks to Anico.ai for providing this specific question in their free resources tab. But before I get started on the explanation, please give this a try. Okay, so here we have an exponential function f of x, and it passes through the points c, 20 and 3c, 1340, where a is a positive number and it's not equal to 1. Which choice is a possible value of b? So first things first, right? We're trying to find the possible value of b, but you'll notice that there's a lot of, well, I don't want to say a lot of, but there's a variables, right? A and b, the constants a and b, right? Usually in a function, right, you don't want to deal with the multiple constants. It just makes it much more harder, right, to approach the problem. So in a previous video, right, I actually used a method of kind of changing this original function into something else. So what do I mean by that? Well, let's define a new function, g of x, right? And let's actually call it f of x plus b. And the reason I'm doing that is because now we don't have to worry about the negative b part, right? We can just worry about these. And you might still not understand why you're adding b, but look at it this way. F of x is a of x minus b, right? And then you're adding b, right? That gives you a of x, right? So effectively now g of x is equal to a of x. See? And that's much more easier to deal with. But, right, let's look at the actual points they give us. They tell us that the function f of x passes through points c, 20 and that other point. So let's write that in function notation. So we have the point that x equals c gives you a value of 20, and an x at 3c equals gives you a value of 1340, right? Now, that's actually going to help us a lot because earlier we defined the function g of x as a of x, a to the x, right? But we also defined it as f of x plus b, right? So what you can actually do is set a of x, a to the x equal to f of x plus b. And this actually makes it much more easier now to solve this problem because now all you have to do is use these points that they already give us, right? So f of c equals 20, right? So that means if you plug in, for example, x equals c, right, you get g of c, right? And again, I'm just plugging c into the function g that we created earlier, that we defined. So g of c equals a to the c, right, because of the a to the x, and that's equal to f of c plus b. And then we have the other point, right, at 3c. So now we have x equals 3c. These are the same exact thing. So you have g of 3c equals a to the 3c, which is also, right, equal to f of 3c plus b. Now, what's the next step? Well, let's replace the values, right? So f of c equals 20. So here we have a of c equals 20 plus b. And then we have f of 3c equals 1340. So we have a of 3c equals 1340 plus b, right? So that's kind of the two equations we get out of this. And you might not realize it, but that's actually going to lead us straight to the answer right here. Because we're trying to find the possible value of b, right? Well, what you'll notice is that you can actually use just a bunch of neat algebra here just to kind of solve for that variable, right? Like, cause look here, right? We have a to the c. But here we have a to the 3c. Well, let's rewrite those for a sec. So we have a to the c equals 20 plus b, a to the 3c equals 1340 plus b, right? What you can do is take this first equation, right, and raise it, right, raise both sides to the third power. And the reason I'm doing that is because once you do that, look, right, you get a to the c cubed. And if you know the exponent properties, you just multiply those exponents together, right? And you get a to the 3c, right? And on the right side here, well, you just have 20 plus b cubed. You notice that a to the 3c here matches the a to the 3c here, right? So what you can do now is take this and that and set it equal to each other, right? You can substitute. So you have 20 plus b cubed equals 1340 plus b. And look, right? You can actually solve for b now, right? I would use decimals here. So I would type in 20, and I'm going to use x instead of b, right? But you have 20 plus b cubed equals 1340 plus x. If you zoom out, right, you get a line that goes through, looks to be x equals -9, right? So in this case, that's just b equals -9, right? And you could zoom out further and further, but as you see, there's actually not going to be any more solutions, right? So that's how you know that, okay, it's probably b equals -9. And just to kind of double check, right, if you plug in -9 into this part, right, you get 20 minus 9 cubed on the left side, and on the right side here, you get 1340 minus 9, right? 20 minus 9 cubed, that's 11 cubed, and then 1340 minus 9, right? But those, both of them equal to the same value. So again, that's just a way to check your answer, but we have b equals -9, and that's going to be answer choice D here. So just to kind of emphasize the most important part of this problem, right? Anytime, right? And this is something I've been showing with a previous question also. If you have a exponential function where you have these multiple constants, right? Your best bet is always trying to eradicate one of those, right? So in this case, that negative b, just get rid of it, right? Define a new function that actually gets rid of that value. And what you'll find is that it actually makes it much easier because you can just plug in the points, and with some fancy algebra, you can get straight to your answer. So I hope that entire method made sense. Please hit that like button and click on that subscribe. We post videos daily to help you on SAT and SAT prep. So if you want to be notified, you should also hit that notification bell. But if you have any questions, all right, leave it down in the comments, and I'll see you next time.